So this is the easiest, hardest question I know. Okay, so if you imagine that this is a piece of string, this string is not knotted, right? So instead of saying not knotted a bunch, I'm going to say that this is the unknot. Right? So that is a picture of the unknot. If you do something like this, you guys see that if this is a piece of string, is that the unknot or not?
Is this what makes it hard? Is just the wording on it, or
No.
Okay.
So is that the unknot?
Well, it's not a knot.
Yeah, it's just twisted, right? So if I untwist it,
Those two ends are
so these two are equal. Right? So you'd say this is also the unknot. Yeah, so this is what we call a representation. So this is the unknot in its optimal representation, and this is the unknot in a different representation. And that thing you did where you guys kind of said, well, you just twist it, right, to get it to be the unknot, that's a thing called a Rademeister.
Well, that thing could never be knotted though, right? Because it's like, like you can make a knot out of it, but it's not.
So if I spend a second and very carefully draw, let's see, so I need one that goes like this and over and then back through. Sorry, that one got small. You guys see that though?
But you couldn't make that out of the unknot, right?
Yeah, I couldn't make this out of the unknot because that is itself an overhand knot. You guys see that? An overhand knot is called a trefoil knot. And the trefoil knot is specifically not this guy. Right? It's not the unknot.
What do you call if you just take the unknot and like stretch it together and then knot that?
Oh, so like an overhand on a bite.
It'd be like that, but doubled up everywhere.
Yeah, so that would be this thing, but doubled up everywhere. So you would make that by doing, let's see. So I need to make the, let's see, so, let's see, that needs to go under and then over this to be the trefoil, right? Okay, so if, instead of connecting the pieces, what Jordan's asking is what if you just kind of doubled it back through? Oops. Oh dear God. Thanks, Jordan, for this picture. Okay, so this thing. Oops. And I have a piece of string that's not connected to anything. How about that string? That is an overhand on a bite. That's what happens when you take this thing and you kind of mash it out and then you loop it back through. That's not a knot.
Why is it not a knot?
Because you could untie it.
But
You guys see
most
that?
knots
Like
you
the
can untie
string
it.
itself is not knotted. This is a question of
Okay.
if this thing was a hairband, right? Could you fiddle it and get the hairband back?
Back to
Yeah.
the unknot.
Without-
Yeah, without cutting it.
Okay.
So this is actually the question. Is there a method to look at a picture like this, right? That's got kind of a string and over and under crossings labeled. Is there a way to figure out whether that's the unknot in kind of finite resolvable time, maybe? Because like the most like the human method is just like we take the picture and you make it into string and then you fiddle with the string.
You could just also fiddle it with
Yeah, or you can fiddle with it in your head if they're easy, right? But once you've got 280 crossings, you're a little bit lost on head fiddling. But you could certainly like think about tweaking it. So this is actually an open question. This is still unsolved.
So if we solve
So
this,
like get a good algorithm to take a picture of crossings and decide whether or not it's the unknown is fully open.
and if we did get this algorithm, that would be like something that you would put on an array of video cards or something to like brute force it down, or are you asking, is there like a minimal?
So what I mean is
effort
you
way
have
get
to,
there?
the object I want is for you to create an algorithm, like something I could look at this mess of crossings and do that would definitely in finite amounts of time tell me whether or not that was the unknown.
With an infinite amount, like approaching infinite amount of crossings, like it doesn't matter how many?
Yeah, with an arbitrary amount of crossings.
Okay.
So I would like that, and I need it to be in finite time, right? Which means fiddle with it is not necessarily an
Do
option.
we have any algorithms for that?
No, that's the problem. This algorithm does not exist. There are some algorithms by which you can definitely tell that something is actually a knot,
It kind of reminds
Right.
me of Erdős' like
but
classroom problem with like meeting people and like you only have so many, like if you have a certain amount of people that come into a room and a certain amount of those people already know each other and a certain amount don't. Like, he says it heck is confusing, but it basically ends up being like a geometric space problem where you have points and you try to like make lines to other points before you inevitably make a triangle somewhere.
Is that the handshake one?
He does, yeah, with like if everyone shakes hands and then like who's met each other when they're.
yeah, so a related problem that you could make with this that would be somewhat similar to the diagrams you're talking about are whether or not two things are interlinked. Right, instead of drawing one hairband, right, I could kind of draw two and ask whether they're actually stuck through one another or whether they're just kind of folded and knotted about one another. You guys see that? So those are similar but separate problems. And there's a whole ton of math that's gone into this theory. Like, this is knot theory at the most very basic level. And knot theory has an extremely cool history in that mathematicians did a bunch of knot theory for like fun, essentially, in the 18th and 19th centuries, and then kind of gave up on it because it didn't seem to have a real serious application to reality. And then in the 80s, people realized that DNA like protein folding was really interesting, and that knot theory would help. So some biologist went to a mathematician and was like, dude, I have this like protein folding problem that I like need to straighten out. And a mathematician was like, oh, that sounds like this thing they used to do back in the day. Let me go to the library and dig out a book for you. Dig out book, hand book. Oh shit, this is super useful. Why didn't you guys tell me about all this stuff? And they're like, oh, we just did that for fun. Whatever. So this is one of the primary examples of like mathematics research pays off even if it doesn't look like it's going to. Right? This one was obviously bizarre, right? Because why would you do this ever? Like, who would care? Turns out biologists care.
Someone eventually, okay.
Yeah, and oftentimes someone eventually will care. Does this kind of make sense? You guys see why this is the easiest, hardest question I know? It's the hardest question I know because it's really like, there have been a lot of people who have spent a lot of time thinking about this and it's not done. And it's the easiest question I know because you can tell a child how to do this in a couple of minutes, right?